Okay, so I'm going to record two examples here for the second bit of calculations you have to do, because these are the ones that typically give people problems. They typically give people problems because if we look back really quick, let me just pull this up, to particle calculations. In particle calculations, the only conversion factor you use is Avogadro's number, and it never changes. This is always Avogadro's number. But in molar mass calculations, we have to use the conversion factor molar mass. We'll get to that in a second. So we're going to have two example problems here. I want to show you a couple different ways you can use this. So anyways, the goal of molar mass calculations is to use molar mass to convert between units of mass, which is in grams. We use mass because that's easily measured. And we convert this between the unit of mole, which allows us to compare ratios of chemicals used in or produced from chemical reactions. Because those ratios, those coefficients used in balanced chemical equations represent molar ratios of reactants and products. So the unit of mole is very useful in chemical reactions. And the unit of grams is very useful physically because we can measure it. Now, molar mass is a bit tricky as a conversion factor because this number of grams is never the same number. Well, let me rephrase that. It's not always or necessarily the same number. This number of grams depends entirely upon what chemical you're using, because this number of grams comes directly off the periodic table. Now, this half, 1 mole, is always the same, because molar mass by definition is the number of grams of a compound per 1 single mole. So there is some easy factor to this conversion factor. Now, when I say that this number comes off the periodic table, I literally mean you have to look at a periodic table to figure it out. And I have this laminated copy, which might not show up so well on the video, but we'll get to that in a second. The chemical we're going to use in both examples is calcium carbonate. Now, I've hit calcium carbonate because it is big. It's a hard chemical to do this for. So CaCO3, it's not easy because this is a compound. So if we want to say what's the molar mass of this, so the molar mass equals what? Well, the molar mass is going to be the number off the periodic table. So we just look at the periodic table and say, well, can we find calcium carbonate? No, calcium carbonate is not on this periodic table, but individual chemicals are. So when we look at this, we have to say what individual atoms make up calcium carbonate and add all of those masses together. So for this compound, we have 1 calcium, we have 1 carbon, and then we have these oxygens right here. We have 3 oxygens. So 1 calcium, 1 carbon, and 3 oxygens make the compound for calcium carbonate. So when we figure out what its molar mass of calcium carbonate is going to be, we have to figure out, well, what's the mass of each of these per 1 mole, and then add everything together. So basically, if I look at the periodic table, I have that calcium. I'll show it to you over here and try and get it close enough so you guys can read. If not, grab your periodic tables and follow along. But calcium right there has a molar mass of 40.08, if I round it. So 1 multiplied by 40.08. And that's the molar mass of straight up calcium. We're going to add to this 1 times the molar mass of carbon, which is 12.01 if we round it. So 12.01. And then we're going to add to this 3 times the molar mass of oxygen. So we have 3 oxygens in this chemical formula. So oxygen is 15.99, which would round up to 16.00. So I'm just going to go ahead and round that 2 decimal places. And then literally in your calculators, just to figure out the molar mass of a compound, you're just typing all this in. So 40.08, I'm not going to bother typing in, times 1 plus 12.01. Again, multiplied by 1 is kind of useless to type in, but here I need to type that 3 in. 3 multiplied by 16. And just to figure out the molar mass, I just say equals, and it gives me the total, which is 100.09. So the molar mass of calcium carbonate is going to be 100.09 grams per mole. Now this is the correct way to write a molar mass. You can also write this molar mass and express it as a conversion factor or mathematical relationship. So a mathematical relationship would be 100.09 grams equals 1 mole. Or you could write this as the conversion factor 100.09 grams per 1 mole, or 1 mole per 100.09 grams. And I'll come back to this stuff at the bottom of this page for these two examples. I just wanted to show you guys this before the examples, because we're going to use the same chemical in both examples. So if you ever have a compound and you're dealing with molar mass calculations, you first have to find the molar mass of the compound by adding up all the masses of its parts. So moving into these two examples. So the first example that I want to show you guys is an example where you're going to have mass given and you have to calculate a number of moles that will be present in that sample. So how many moles of calcium carbonate were produced in a reaction that made 0.79 grams of calcium carbonate? So as in any word problem in chemistry, figure out what you're given, because that's where you're going to start. We're given that number, and ask yourself what you're asked to calculate. Well, we're asked to calculate how many moles of calcium carbonate we have. So we're given this number. This will be where we start. And we're asked to calculate this number, so this will be where we end with our dimensional analysis. So we have a starting point, and we have an ending point. Your starting point is going to be 0.79 grams of calcium carbonate. Now, when you're using conversion factors, you're doing dimensional analysis, you want to get rid of the units you start with. So down here on the bottom, grams of calcium carbonate. Going to go on the bottom of our conversion factor. Now you're like, okay, what's the conversion factor here? Well, we're asked to go from grams to moles. You have to know that the definition of molar mass is a number of grams equal to 1 mole. So if you're ever given the units grams and moles, you're using molar mass. So you have to be able to realize that. Now we've already calculated the molar mass down here. And we've actually already written a couple conversion factors over here. So if we look at these conversion factors and look at our problem, I have 0.79 grams of calcium carbonate. Grams need to go on the bottom. So this 100.09 is going to be the number that goes on bottom, and the number that goes on top will be the other half of my relationship. Notice I have this conversion factor already written out right here. So it's going to be 1 mole of calcium carbonate on top. And grams of calcium carbonate will cancel out, and I'll have my answer. Now remember, when you type this stuff into your calculator, just to remind you guys, I have to adjust where everything sits now because of the glare, but when you type this into your calculator, you're going to start with this first number, 0.79, and if you're dealing with the number on top, you multiply, but that's a 1, so we can ignore it. Anything multiplied or divided by 1 goes away, so we can ignore the 1. So we multiply across the top. But if it's on bottom, because this is a fraction, we are multiplying by a fraction. If you multiply by a fraction, you're in essence multiplying by the top number and dividing by the bottom number. So in your calculator, you'll say, okay, 0.79, that's on top I multiplied, this is on bottom I divide. So I hit the division key, 100.09, and then hit enter. Now notice I have a very small answer here, which you should if you think about it. To have 1 whole mole, I would need 100 grams, but I have less than a gram. So I'm not going to have anywhere near a mole. So my answer is going to be 0, and then I have 2 zeros, and then I want at least 2 decimal places. I'll use 3, so 0.00789. Now this number, I don't really like writing numbers like this, because it gets really long and I don't really have room to write the units here. So I would express this number in my answer in scientific notation. 1, 2, 3, to move the decimals 3 times to the right, times 10 to the negative third, and my units would be moles of calcium carbonate. Now, you don't necessarily have to write your answer in scientific notation units, but sometimes your answers will be so big or so small that the calculator will give them to you in scientific notation. So don't be afraid of scientific notation. If you are, you need to go back and review that from the beginning of the year a little bit. You'll see it from me a lot in class. But yeah, you could just express this answer if you wanted to as that. 0.00789. The lights in the room just cut off because apparently I've been sitting here doing these videos for too long. So this is going to be a longer video. I'm going to do the second example for you guys and then quit out of here. At least the light adjusted down so you can still see what's going on. The second example is going to be a lot shorter because I'm just going to kind of work through it really quick. You've already saw one example. You've already got some explanations. So this is practicing. By the way, if you want to pause right here and give this a shot, that might not be such a bad idea, but that's up to you guys. So this is a mole to mass calculation. It's the opposite of the calculation you just did. So a reaction should produce 3 moles of calcium carbonate. What mass would this be? So you are given 3 moles. So this is your given. And you are asked to calculate mass. So this is going to be your starting point, and this will be your ending point. You want to be able to read the word problem, and you have to be able to figure that out on your own. That's where this stuff gets difficult, right? So we're starting with 3 moles of calcium carbonate, and we're going to be canceling the unit of mole, and I want to get to the units of mass. Well, what are the units for mass? Well, mass is measured in grams. So I'm going to be going from moles to grams. Well, moles to grams, that is the standard units of molar mass. I've already figured out the molar mass of calcium carbonate earlier, 100.09. So the grams would go on top, 100.09. The moles would go on bottom. And notice, I'd already written this conversion factor out right there. But whenever I do this, I actually look at the relationship. So just put the numbers where they go. Calcium carbonates, moles calcium carbonate cancel out, and essentially we just have 3 times 100.09. Don't even need to use my calculator for this one because 3 times 100 is 300. 3 times 9 is 27, so this would be 300.27 grams of calcium carbonate. And hopefully I can still do mental math, but I'm just trying to get through with this so the video doesn't last too long. Anyways, there's some examples of how to do these calculations. Ideally, you guys can pick this up and have these done and ready to go by tomorrow.